Work energy theorem, part 2. So we've already reached the conclusion that the work done on an object, work is the force exerted multiplied by delta x, the distance the object moves, multiplied by the cosine of the angle between the force and the delta x. If I have an object here and I apply a force in that direction, pick another color for a displacement vector so that we're clear that they're different types of thing, delta x, then the angle between the force and delta x is needed to figure out how much work's done, because it's only the component of force along that direction that does the work. Now if F and delta x are in the same direction, like so, then, and let's say that to the right is the positive x direction, then force and delta x are both positive and work is positive, greater than 0. And if you think for a little bit, if you're applying a net force, this is always going to be any unbalanced force to do net work, in the same direction that something is moving, then you're going to be getting an acceleration in the same direction that the object is already moving. Or, put another way, the speed of the object is going to be increasing. V will increase. And as a result, the kinetic energy will also increase. So positive work done on an object means there's going to be an increase in velocity, which means there's going to be an increase in kinetic energy. Another possibility exists in which the net force is in the opposite direction from delta x. And so if something is moving from left to right at a certain velocity, and then you apply a net force against that, the result is that you're going to slow the object down. And so that's going to cause a decrease in velocity, and so there's also going to be a corresponding decrease in kinetic energy. And so if we look in more detail at the work energy theorem, the work done on an object is the change in kinetic energy of the object, which is always the final kinetic energy minus the initial kinetic energy. And so if it slows down, then the final kinetic energy is less than the initial kinetic energy. This quantity is negative, and so this quantity over here is also negative. So positive work, force and delta x in the same direction, you're increasing the speed, increasing the kinetic energy, doing positive work on an object. If the force opposes the motion, then you're doing negative work, which means you're decreasing the kinetic energy. And a ubiquitous example of a force that always opposes your motion and therefore always does negative work is friction. Friction's always going to do negative work.